Hello, welcome back to the second part of these problems where I'm just solving by factoring. So again, if it's already set up equal to 0, factor the quadratic expression part and use the zero product property. So you'll see me do that. If it's not equal to 0, then move everything to one side, your choice, doesn't matter, so that you will get the expression equal to 0. And in this one, we're going to have to do something else, but let's just hold that off for a second. This one's nice. Sorry, starting off, we don't have to do any steps to get it ready to be factored. So what two numbers multiply to give positive 16, but add to give negative 8? That's going to be x subtract 4 times x subtract 4. Now notice that these two terms, these two factors, x subtract 4 is the same as x subtract 4. So it's kind of redundant if I do x subtract 4 equals 0 and then I do it again. All I need to do is solve it once, get x equals 4, and then just mention I actually get that solution, that root to the equation, I actually get it twice. Don't forget, you always get two answers. Now, if you did x equals 4 or x equals 4, and if you just say it that way, I know what you mean. And there's different ways of saying the same thing. So it's okay. It's okay if you just write the word twice. For problem number 14, let's get this negative 3x squared over to the other side. So I'm going to add 3x squared to both sides. And I'm going to make sure I put the other side in standard form. So I get 0 equals 3x squared plus 18x plus 27. Okay. Now I could start factoring using my diamond method because I've got a 3 in front of the x squared. But I do notice this. That's a multiple of 3, That's a multiple of 3, and that's a multiple of 3. I have a common factor of 3. So I'm going to divide everything by 3. 3 divided by 3 is 1. Well, that's nice because I got x squared. 18 divided by 3 is, 6. And 27 divided by 3 is 9. What two numbers multiply to give 9, add to give 6? That's x plus 3 times x plus 3. And just like this problem, I'm going to get the same root twice. Okay, so looking over these problems, I have to do something with the 12x. Move that over to the other side. This one's nice, set up for me. This one's nice, set up for me. This one, I got to do something with the negative 18 and probably got to do something with the 2. So I got like a nice little variety here, but these two are going to be kind of okay for me. This one's okay, it's not bad. All I got to do is add negative 12x to both sides. And bear in mind, I want to put it in standard form. So I get x squared subtract 12x plus 36 equals 0. So when I added negative 12x to both sides, I put it in the middle here. What two numbers multiply to give positive 36 but add to give negative 12? X subtract 6 times x subtract 6. So another example where I'm going to get the same thing twice, the same solution twice. X subtract 6 equals 0, add 6, and I get x equals 6, and make sure you mention that you get it twice. What two numbers multiply, for number 16, what two numbers multiply to give 49, but add to give 14? That's going to be x plus 7 times x plus 7. Now, I'm hoping that maybe you've started to see a pattern here. And I'm going to finish this one, but I just want you to see this pattern here, okay? 16, 9, and I'm looking at this part. This is after I did the greatest common factor. 16, 9, 36, and 49. What do they all have in common? And I'll give you a heads up, 64 also has the same thing. Well, 16, 9, 36, and 49 are all perfect squares. So I get all of, I get the simplified form and standard form for multiplying 7 times 7, get 49. Here I get negative 6 times negative 6, I get positive 36. So one thing I can do is if I see, like this one right here, this one has a perfect square. 64 is 8 squared. And also, not only that, but if I say, all right, well, 8 times 8 equals 64, and 2 times 8 is 16. It's negative, so it'd be like negative 8 and negative 8. 2 times 6 was negative 12, or actually 2 times negative 6 was negative 12. 2 times 7 is 14. So I'm seeing a pattern here for my factoring, and that might help you factor things a little quicker so that you're not, you might not have to go through the list of all the things that multiply to give that number. So that's kind of nice. I get x plus 7 equals 0, add negative 7 to both sides, and I get x equals negative 7. And one more time, I get it twice. Over here, this is going to be x subtract 8 times x subtract 8 equals 0. Because 64 is a perfect square, it's 8. 8 plus 8 equals 16. But it's negative 16, so I'm going to make both of them negative. I get x subtract 8 equals 0. Let's isolate the x and get x equals 8. And we'll mention that we get it twice, one more time. Finally, for problem number 18, let's move that negative 18 to the other side. I get 2x squared plus 6x plus 18 equals 0. I notice that that's even, that's even, that's even, so I can divide a common factor of 2, and I get x squared plus 3x plus 9 equals 0. Now I say, what two numbers multiply to give 9 but add to give 3? Okay, so what multiplies to give 9? It's 1 times 9 and 3 times 3. Neither one of those are going to add to give 3. So guess what? Sometimes this happens. I mentioned this in the previous video. This one cannot be factored. Now, it is possible that I can solve it, but I need to learn more tools before I can solve for that one. So sometimes you get it to where it cannot be factored. All right, we'll see you in the next video.